Hello everyone, welcome to the video. This is a video demonstration for my MSci full unit project on neural networks. What I'm going to demonstrate in this video represents a final program that I will be demonstrating during the summer term that represents part of essentially a end product for the work I've been doing over the past year. It is a live MNist program which is able to take in scanned images of physical handwriting of numbers in between 0 and 9, reformats them to a suitable format via conversion methods, and makes them into a suitable format for MNist objects, and is able to predict their values once trained and then tested on from a Keras-dense neural network. What I think this final program allows me to show is not just the knowledge I have learned over the last year in terms of neural networks as a whole and even Keras and TensorFlow, but it also allows me to have some element of interactivity between, the work I have done as well as any individual who is interested when seeing my booth at the demo come the demonstration. So that being said, let's get to it. So the first thing we need to do is draw in a handwritten signature in between the values 0 and 9 so that we can scan it and send it into the program for it to make a prediction on it. For the sake of this video, let's draw a 3. Doesn't have to be the best looking 3 in the world, it just has to look like a 3 in your eyes, because that way we know, through validation, it is a 3. There are a few ways of getting this into the computer so that we can run it through the program. You can scan it via a printer or scanner. However, on the demonstration day, I don't feel like dragging my big printer all the way to the demo. So that instead, I have downloaded an app on phone, which I have checked is available both on iOS and Android, called Cam Scanner. Let me see if I can focus this. Cam Scanner over here. Once over here, which basically is an app that can scan documents and basically send them as JPEGs or PDFs to any situation. So let me just take this over here. I want to make sure it's in focus. Here. Okay. So once you have this, you're then prompted to essentially focus on what parts of the image you want to scan. For the best results, I recommend focusing these lines as close to the actual digit as possible. So somewhere along the lines of this. Once done, you then click the check button, and that should make an automatic scan of your number. Once done, don't worry about the filters. You just click next. It'll save the image. And that is our new formed image. We can click on this, go to more, please. Okay. And what we essentially want to do is send it as an email to myself, essentially, or I could even Dropbox it to myself, just any way such that we can obtain it from our phone's picture library onto the actual computer itself. Okay, so I've obtained the scan via the email, and I have placed it on my desktop and have renamed it as Handwritten 3. So that is now a JPEG scan of our number that we have just written. And let me just pull up a little bit here. This over here is the entire program for Live MNist, which is the final program that I'll be primarily using for demonstrating during the demo. I could go into full detail with the code, but the only thing that's really relevant is this right over here, which is input file name and output file name. The name of the file containing the scan image that we want to be our test has to have the same file name as whatever is placed here. So I've done that in advance, but that is essential for the program to run. If it's named something else, the program will return that it cannot find it, or it might even run on the incorrect image. And we definitely don't want that. This program, by the way, is also here. Both the actual program and the scan that we want as a test are within the same directory. In this case, my desktop. And over here, I have already set up a terminal, basically building up the environment that we need in order for the program to run. Okay, I first navigate to desktop. I then create a conda environment of Python 3.4 that implements matplotlib. Conda is a Python environment creating tool for terminal, which essentially allows for creating sandbox Pythons or Python sandboxes in terminal rather than completely reviewing and renewing your Python version in your terminal itself. Rather, it creates a kind of virtual box, but more for terminal itself, for different versions of Python. And matplotlib is needed for actually presenting the reformatted scanned image in MNist format. So I go over here, I create the environment, I activate the environment, as seen here. My path is no longer desktop, it is demo environment desktop, to show that we are currently within this new Python environment. From here, there are 3 prerequisites that need to be taken, and all of 3 of them can be installed using pip. There's pip install TensorFlow. TensorFlow is a Python machine learning based language, or library, I should say. There is pip install Keras. Keras is an API for TensorFlow that allows for simple neural networks to be developed. And finally, pip install Pillow. Pillow is a Python image modulation library, which will be needed for actually converting the scan that we have into the correct format of MNist. But all this time I keep talking about MNist, I figure I might as well say what it is. MNist is a database of over 60,000 ND arrays, which are basically lists with different values, of 784 elements long, where every element is a value in between 0 and 255. I'll get one of those in a minute. But the reason it is 785 is because that represents a 28 by 28 image of a digital number. So the program essentially, what we wanted to do is take this image, convert it into a 28 by 28 image such that it is in the correct format for MNist. Of course, once we do that, we then deresolute it so that, you know, it's on the same pixel levels as any other MNist objects. And from that, we simply test it as if it were any other MNist object we were testing for to try and predict what number this is. So yeah. Okay, so with all that done with the way, I have typed in Python live MNist, and I'm about to press enter, and I will show you what the program actually does. So it opens the TensorFlow backend, which means it's opening its neural network. This is a summary of the neural network that we are creating. Sorry if it's juddering up a bit, but it has layers of dense layers, it has dropouts, and of course, most important to note, its final layer is an output with 10 different classes, those 10 representing different values between 0 and 9, what it thinks is most likely prediction. Of course, it is training on images that are currently in MNist. It's training for 20 epochs. And of course, if we can have a look slowly, these values over here, oh, well, as you can see, the output gives the loss of the neural network, which basically represents, as we train, how much offset do we go by. The test accuracy, which basically says, once our network has fully trained, how accurate we are in our readings. And of course, the error rate is thus 1 minus this. And as you can probably tell right here, our program predicts a 3. That is correct. And then I should also back up here. So what I was mentioning previously with the 28 by 28 pixels with values in between 0 and 255, this is 28 by 28 ND array, which essentially lists the grayscale values of each individual pixel, where 0 represents a pure black cell and 255 represents a pure white cell. So basically from different colors ranging from black to white. And from that we can obtain what cells or pixels rather are actually activated. And as you can tell here, you can kind of make out the actual 3 that we actually had. And if I pull back here, the program once run will also pull up a MNist image of the now converted scan. So let me just pull this up just for comparison. Yep, I think that looks pretty similar. Something to note, the program does not terminate until you actually close this image. I was going over the footage and I failed to mention that the output of the live MNist program also produces a file within the same directory as you are running the program. And that file is the actual MNist reformatted image of the scan that you had. So if I can bring this up, yeah, it's pretty much the same as it is. This is essentially now a actual JPEG file, which is the scan that you made within handwritten format. So you can feel free to use this for any more of your MNist experiments. And with that being said, that is my demonstration for my MNist project. Thank you for watching. I will be demonstrating this at Royal Holloway University of London on April the 23rd of this year. Yeah, what else can I say? Thank you for watching. Unfortunately, I cannot make this public just yet because, you know, it is part of my project and it is technically part of the university. However, once it has been assessed and, you know, once everything is in order, I will attempt to make it public and update the description so that if anyone is interested, they can try it out for themselves. As for other YouTube stuff, I do plan on uploading a bit more in the future. So, you know, this is where I do the typical YouTube stuff. If you like this video, don't forget to leave a like, you know, and hit the bell. I think it's in one of these sides. I don't know. It'll probably invert the image. Anyway, have a good one. Now, if you excuse me, I have a 15 to 20,000 word essay I need to finish in just under 2 weeks. This will be fun.